What do you do when you've dropped out of college 3 separate times without finishing a single degree?
My mother's very proud.
Started a YouTube channel in the hopes it would motivate you to learn some new skills, but you're still so bad at designing PCBs. Well, if you're anything like me, the answer to this problem is obvious. Stealing. Our target? Mr. Beast. The item of interest? These devices worn by the contestants in a Squid Game video. These boards have a lot of things I want to learn about, and I think I should be able to use my intellectual might to reverse engineer them, forcibly open source them, and hopefully, finally, I'll be able to look into a mirror and not be ashamed of myself. So what actually is this thing? Do you need to shoot somebody with a gun and film it and still have the person alive afterwards? Well, then you need a squib. Professional squibs use explosive charges to spew blood and gore, but if you're in a pinch, there's nothing stopping you from building a pneumatic squib out of plumbing parts like this one here. But if you're Mr. Beast, you can just hire fellow YouTuber William Osmond to design and manufacture a completely novel PCB-based squib for your video. I'm not totally sure how they work, but we know they're battery-powered, triggered wirelessly, and use some sort of pyrotechnic to release the squib juice. Will's video on the design process is going to be our main source of clues, but we'll also be supplementing with a few podcast episodes that expose a few key details. So let's go ahead and get started with... When I first sat down to skim through Will's video, some things jumped at me right away, like these Discord screenshots. They're not quite as scandalous as your average group chat leak, but they do contain the exact part numbers of both the battery holder and wireless module. It's a bit of an older microcontroller, but it's cheap and it supports Wi-Fi. One difficulty is that unlike a dev kit, this is the real deal, and I have zero clue how to get code onto one of these, but that's a problem for later. For now, let's watch a few more seconds into the video and we see the entire PCB stack-up gets flashed on screen. I took screenshots of these and traced them in Inkscape to get a pretty accurate board outline in silkscreen. Hey, look at that! So far we're blazing through this PCB, but we've only tackled the stuff that's pretty much been given to us. We still have no clue what this chip is, what these explosives are, or how to control any of it wirelessly. So let's put our latex gloves on and dive into... First mystery is this chip here. I mean, it's not that much of a mystery. The label right next to it says boost, which probably means it's a boost converter. AA's can actually deliver quite a bit of juice, but their main downside is they're dropping voltage. That will make our microcontroller very unhappy, but thankfully the boost converter is here to save the day. This chip uses black magic to take a dropping DC voltage and output a stable 3.3 volts for our microcontroller. The PCB screenshots from earlier indicate that this is a boost converter with 8 pins. And because of the choice of microcontroller, we know it has to be able to at least supply 170 milliamps. I plugged that into a parametric part search and found these 3 options, but I'm pretty sure it's this one, and this blurry screenshot is the key. Now this is a bit of a stretch, but just stay with me here. This chip looks like it has 3 rows of characters, and if you squint really hard, it even kind of looks like the exact letters we'd expect for this model. And since the pinout seems to match, that's good enough for me to mark this one off our list. Now let's talk about the business end of this device. This bag of liquid just looks like normal water with food coloring, and I suspect they had some poor Mr. Beast intern spend all day using a heat sealer, because that's exactly what I did. At first I was a little hesitant with the sealer, and the squib bags ended up having a lot of air that made them super floppy. But after some experimentation, I figured out you can seal directly through the water, leaving a perfect seal. Early in Will's video, they seemed to be prototyping a mechanism that used a hot nichrome wire to slice the bag, but at some point they switched to these little pyrotechnics. They don't explicitly describe what they are, but near the end of the video I saw this URL on the side of a box, and visiting it led me to a page that was selling rocket motor igniters. These look exactly like what they used, and just a few weeks later I was the owner of a few hundred of these guys. Just apply a few volts, and they pack quite the punch for their size, and more importantly, they're the only brand of e-matches that are legal to own since they were regulated by the ATF in 2003. Don't worry, I definitely bought Firewire brand igniters, not sketchy Chinese knockoffs from for the price of like before realizing that I might be committing a crime. But to figure out how to pop squibs with them, I set up a few experiments on my back porch. First, I just tried taping the e-match to the front of the bag. A little underwhelming to be honest, but I figured maybe the e-match wasn't sealing against the bag well, so I went caveman mode and hot glued the e-match directly to the bag. That worked excellently, exploding the entire bottom of the bag and letting all the liquid out at once. But this is different than the single stream of liquid we see in Will's video. You remember how I mentioned those podcasts earlier? Episode number 27 of Safety Third Podcast basically tells us everything we need.
We'd heat seal one end of the straw, stick the fuse and the igniter in, then put hot glue on top of it, and then clamp it shut with pliers, and then poke a hole in the top, or in the side.
This looks like how the igniters in the video worked, and even produced the single stream of liquid that we want. And after doing some brute force googling to find the e-match connector, We're ready to make our first PCB. Battery connects to boost converter connects to microcontroller connects to MOSFET, and MOSFET to E-match connector. What's this for? Turned out the microcontroller is too weak to ignite the E-match by itself, but a MOSFET can source amps of current directly from the batteries, and can still be turned on and off by the microcontroller. But finally, we're ready to get this board manufactured, and as usual, my choice of fabricator is PCBWay, the sponsor of today's video. I just gotta say, I am so glad that I didn't get into electronics 20 years ago, where I would have had to mess around with toner and corrosive chemicals to make my own PCBs. And the only other real alternative was creating an absolute spaghetti fest of wires on some perf board. But thankfully today, companies like PCBWay have come to save us from these tribulations. Design your amazing PCB in whatever software you like, and when you're ready to turn those suckers into real fiberglass, you can either upload the Gerber files yourself or use one of PCBWay's plugins to automatically create the order for you. Now, I generally assemble my own PCBs because I enjoy the smell, but PCBWay also offers assembly services if brain damage isn't your style. And I'm especially excited because my PCBWay rep just let me know that turning your PCBs purple is free for the entire month of September. And even if you're a bit of a numbskull who doesn't have the brain cells to learn CAD, there's PCBWay's shared projects marketplace. I'm pretty interested in these guitar pedal PCBs, but there's plenty of other cool things on here you can buy fully manufactured and assembled by PCBWay. And even if you don't need a PCB, PCBWay has a whole range of services, ranging from injection molding to laser cutting. As always, thanks to PCBWay for sponsoring today's video. And now let's get back to whatever I was up to. And now that we have our beautiful PCBs, let's put together this board. Wait, what the f is this? Is what you're probably thinking, because this is definitely not the microcontroller I showed you earlier. Gonna be honest, I took one look at the datasheets for this guy and dread immediately overtook me. So at least temporarily, I decided to use a dev kit I'm familiar with. But don't worry, once we make sure this board works, I should be able to buckle down and put all my focus towards remembering how reading comprehension works. I mean, what do you expect from somebody who dropped out 3 times? But right now, we've got a big problem. This board doesn't work. This is the power LED, and it should be on, but obviously something is wrong with the power supply circuitry. I figured that my shaky soldering hands were to blame, so I started resoldering random parts on the board, for some reason while the board was still powered on. I guess getting a face full of sparks put some sense in me, because I checked the datasheet of the boost converter and realized I had soldered it on upside down, which somehow hadn't broken it, and can just be fixed by flipping it back the right way again. Well, that works, I guess. But right now, this guy is about as useful as a brick. We need some firmware. Okay, so detonating the Squib is a single line of code, but how about wirelessly? Is it Bluetooth, Wi-Fi, or some other obscure protocol? Thankfully, we don't have to guess. Listen to how Will describes it in this podcast.
We like, it's low-level Wi-Fi, so it uses Wi-Fi, but it's not Wi-Fi. It's like really shitty Wi-Fi.
Not super helpful, but I vaguely remember something from my research that sounded like this. A protocol called ESP Now, which uses the same radio as Wi-Fi, but without any of the extra nonsense. My computer runs a web server, which serves up a web page used to control the Squibs. It looks like the MrBeast crew actually use a native iOS app, but a web page will work just as well, and I refuse to write code for Apple devices. This web page lists all the Squibs, and when you're ready to detonate one, select the Squib, arm it, and then press trigger. That sends a web request to the server with the Squib ID, but the server can't speak ESP Now, so I had to enlist another microcontroller to act as a bridge, taking messages over a serial link and broadcasting them to all the Squibs with ESP Now. Each Squib will receive the message, but only the one with a matching ID will actually trigger. In my neighborhood, this setup had about 200 feet of range before losing packets. But if you use the illegal transmit power hack the MrBeast crew used, you should be able to get much further. FCC violations aside, I think it's time to try the Squib out. So we're here in my garage with my boy Jacoby here, and we're gonna be testing out the Squib. I was a little worried that my computer wouldn't be able to send signals down here, but as we can see, if I arm it, yep, seems to work fine through 3 levels of a house. So I brought down
piss.
I've got some pre-made igniters, and I've got my hot glue gun and impulse sealer and rubber bands, and we're gonna try and just do a couple demos of this.
There is our little piss bag here. All right, here's the finished squib. 3, 2, 1. Oh, there's no battery in it. Okay. All right, 3, 2, 1. Oh God, why didn't it go off? 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. Why is it not triggering? If this doesn't work, I'm gonna fucking scream. 3, 2, 1. That worked fucking awesome. 3, 2, 1. 3, 2, 1. 2, 1. 1.
But now I need to fulfill my promise to you and answer the question that's been plaguing me since the beginning of this project. How the fuck do you program one of these? Your average dev kit could be programmed by a mildly competent hamster with a USB cable and a laptop, but the datasheet for this guy doesn't mention USB even once. So I went back to look for any clues that might help us. The best I found was this, the programming cable that they used. I brought the PCB screenshots we found earlier into GIMP, adjusted the opacity so we could see all of the traces, and then traced out every single connection between the cable and the microcontroller. Obviously, that's not going to help me understand how this works, but it gave me something to start with, and now we can cross-reference the datasheet to figure out exactly how it works. Okay, so we've got power, ground, and serial connections, but also these two mysterious ones. What the heck are these for? Well, one connects to the reset pin, and the other to this pin, which can be used to select two different modes. On boot up, either run whatever program is already in Flash, or wait to receive new firmware over the serial link. So by automatically controlling these from software, you can reset the microcontroller into download mode, upload the new program, and reset it again. This gives you the same seamless experience of programming a dev kit, which often just have the USB to serial converter built onto the board instead of in a separate cable. This blew my mind, and now we can finally replace a dev kit in our schematic with the real deal. And after a couple more weeks of waiting, we have what should hopefully become our final PCB. I assembled a minimal version of the board with just the microcontroller and some status lights, so we can try and flash a simple blink program to verify I didn't royally mess this up.
Alright, if this explodes, I'm gonna cry. Okay, the LED is on. I'm really nervous, but I gotta go for it. Oh my fucking god. It's working. It's going really slow, but it is working. Dude, let's fucking go. It's straight up just working. I have leveled up as an engineer.
So I went ahead and finished assembling the board, and now I can show off one big improvement I made. This eMatch connector was pretty unreliable and hard to reset, so I replaced it with this other eMatch connector that works way better and even has a little lever to make things easy. But even still, a visual indicator would be nice, so I added this LED that lights up when the eMatch is properly connected. Besides that, these boards are basically the same, but let's test them out anyways. And to make things a bit more fun, I modded this airsoft gun to turn it into a squib trigger.
3, 2, 1.
Our squib seems to be working as good as ever, but how about with a shirt over it?
3, 2, 1. Okay, there's a hole burning in the shirt.
And by now you've probably noticed these guys have less of the visceral blood spewing action of a normal squib and are a lot more of a controlled leak. It also might definitely burn you unless you take care to protect yourself from any sparks. I just wore 2 shirts to protect me.
Goodbye, cool world.
But my goal was never to make a perfect squib. I just wanted to steal a PCB design from Mr. Beast and hopefully learn a few things along the way. I might still use dev kits in future designs, but now I know I can use a module like this if I ever need to. If you're a turbo nerd like me, feel free to take a look at the public GitHub repo, where I've uploaded all the firmware, PCB designs, and server code. The documentation is still pretty sloppy, but hopefully I'll be able to update it as soon as I recover from the nightmare that was editing this video. And of course, thank you to my patrons for supporting projects like this. I was planning to release a different video much sooner, but the original product I was working on was boring and dumb and stupid, and I got frustrated. Maybe you'll see that project eventually, but this next video should be pretty quick. Let's just say it has something to do with this PLC and my ass. If for some reason that intrigued you, check out my Patreon to get progress updates. And you'll also get access to my exclusive Discord server if you want to just harass me.